Hey, hello, Calculus 2. Welcome back. Exponential growth and decay. Uh, a lot of things act like this. We talked about populations growing. I think I did a radioactive decay problem where the amount of stuff was decaying exponentially. This is some real data. This is the world population of humans. And these are some real data. In the year 1171, we had 0.375 billion humans. By the way, that's 375 million population worldwide, world population. That's interesting. In the year 1500, half a billion, 500 million or half a billion people. In 1804, we finally hit 1 billion people. And in 1927, we hit 2 billion people. I'm not sure if you know, right now we're right on the cusp of 8 billion. We're about to hit 8 billion people. So, if this data followed the model, y equals c e to the kt, the classic exponential growth model, and if I use this data to try to predict the future, I want to see what would happen. So let's see what happens. So here's what I do. Forget the other pieces of data for a minute. I'm going to use those two pieces of data. I'm going to call this year t equals 0. If I call that year t equals 0, then I'm going to call this year, let's see here, 329 years later in the year 1500. And so what we need is we always need two pieces of data to get the C and the K. And then we can predict the future. So the question is maybe what's the population today in 2020? So that's the question. If I use these two pieces of data, here I go. If I plug in t equals 0, that's e to the 0, there's c, and what's y? Y is the 0.375 billion people. So I just discovered c is 0.375. There's the math that shows you that, and we already said that also. Whatever corresponds to t equals 0 is the c in this model. In this model, that c is the initial amount corresponding to t equals 0. Anyway, that piece of data helped me find c. The next piece of data, when t is 329, here's my c. I don't know k, but when I plug in 329 for t, I can plug in a 0.5 billion for the y, for the amount of people. And I can use this to find k. Of course, you divide. This is easy algebra here. I don't really have to do these for you, but I wanted to show you something. So if I divide 0.5 divided by the 0.375 is a little 1.33333333 forever. Then you take the log of both sides. That cancels the e. That leaves you with k times 329. So then you divide by the 329. So sorry about that. I just did 5 algebra steps in one. I divided. I took the log of both sides, and then I divided by the 329 to get k. And that's my k. I can find out what that is. I can take the natural log of that 0.333, and I can divide by the 329. Oops. And I get this value of k. K is 0.008744136. I rounded that just a little. I told you not to round it, but I just barely rounded it way out there. Yeah, that's my k. And if I have the model to predict the future. So y equals my c was this starting amount of people in the year 1171. E to the k, I'm just going to use this as my k, 1.33 all over 329 times t. This is the model, and then I wanted to predict what the population would be in 2020. And so, oh boy, going back to year 0, well, how many years is that? 829 plus 20, 849. I think this would be 849. Going back to 0, from 1171 to the year 2020, I think that's 849 years. Did I do that math right? I can subtract it. Of course, I did it right, of course. Okay, so plug that in and let's predict how much the world population is today. So I'm plugging in, I don't know why I'm writing all this for you. Divided by 329, all raised to the 849. I'm sorry. That's not quite the way to say it. 849 times this is the exponent for the e. So here we go. 849 times that k that I just had in there, which was the natural log of 1 point. Equals that, and then I multiply by the 0.375. No, then I e it. Sorry. E that answer. And then I multiply by the 0.375. Oh, jeez. And I get 0.787 billion. Did I do that right? You know, it's a shame to do all this work and screw up your calculator. Let me try this again. The natural log of 1.3 divided by 329, that's my k. I multiply that times the 849, that's the years. I raise that to the e, I e that answer. And then I multiply that by the 0.375. Sorry you have to watch me do a calculator, but you can do it. Yeah, dude, that's terrible. That's a terrible prediction of today's population. That data did not predict today's population at all. It's not even a billion yet. Do you know why? I think the rate of growth of the population in those years, even though it might have been an exponential rate of growth, I think the rate of growth is changing. And, you know, there's a lot of plagues. There's a lot of bad stuff happened in the year 1300, 1200. Yeah, that took a big toll on. Let's just start over. Let's use this data. Let's use this modern data to predict the future. All right, here we go. Bear with me here. Same model. I'm going to ignore that original data. That produced a terrible, the rate of growth of the human population is growing at a bigger rate than that data projected. Yeah, it's probably growing at a changing rate. I mean, we're assuming that this k is a constant, but I think k keeps changing. And if I use this data, I'll have a different k. So let's see what happens. So we're not using that data. We're going to use this other data. We're still going to do the same problem. This is going to be t equals 0. This is going to be t equals, what's that, 123 years? And the population doubled? Okay. If I plug this in, by the way, guess what C is? C is that original population, 1. So C is 1 billion. I'm going to plug in 2 billion for the amount of people. C is a 1. E to the k, I don't know k, and I'm plugging in 123 years. So I'm going to find a different k. I'm going to leave this old k up here for fun. What do I do? Take the log of both sides. I get the natural log of 2. That cancels the e. I divide by 123. This is my new k for this since 1804. Starting in 1804, what did the population do? So let's see what that is. Let's see what that is. Natural log of 2 divided by 123. 0.0056. That's quite a bit better. 0.0056. Yeah, that's a different k. 353429 if I wanted to write it all out. But there it is. There's my k. And that's quite a bit bigger number than this old k. So now let's see what can we predict the future. Starting at t equals 0 and 1804, 2020 now becomes what year? 216, right? 216. So I go to my model. I got my C is a 1, my K is this, and I should plug in 216 to predict the future. Here we go. C is a 1. You don't have to write 1, but I do for fun. K is this natural log of 2 over 123 multiplied by the t, which is 216. And we have a new model for population growth, and this will predict the future. Let's see what happens. Let's see what happens. There's one. Wow. Okay. 3.38 billion people. That's the population in 2020. Guess what? That's wrong. That wasn't good enough. So again, this K, using these data points, this K was trying to predict the future, and again, it's the K changed between now and then. I mean, the K is growing. Because of what? Well, we got better health care, we have better infant mortality. A lot of infants would die back in the 1800s, early 1900s. We've got a lot. Yeah, I should use some more modern data to predict the future. Do I have any more modern data? Actually, that's all I have. I need to exclude that 1804. I probably should start here. I should get some more data from 1950, 1960, and use that data to predict the future. But the truth is, what I've read is in 2024 we should hit 8 billion. And the other truth is this population of people is not really growing. Well, what we just learned is that the K keeps changing. But even if I use some more modern data, it's growing like this, but now what's gonna happen is the K's tapering off. So what the current trend is, we're gonna taper off and we're gonna approach about, I mean, we're here at about 8 billion now, but we're gonna approach about 11 billion by the year 2100 and taper off, kind of approach that. And we'll look at a curve like this. When you look at a curve like this, this is called a logistic curve. This is not this model. This model is just crazy exponential growth. And apparently that's not really what the future holds for us. But anyway, you can use it to model certain things, but you can tell how some predictions are off. All right, so that was fun. And that's some real population data for you. And I just showed you how it didn't work. Great.